So hello everyone, I created this video today because I wanted to help you with unit conversions. I really want you to be able to do these easily. And I know when you're not used to them, it's a bit challenging, but hopefully with the tricks I'm going to give you today and the little, go to the pointers and the steps that are involved in unit conversions, hopefully you'll get you get to understand how we make those. Now, don't forget that practice is key here. So the more you do them, the better you'll get at it. Don't worry, it'll come. It's just to understand the relationship between each value, and once you understand the relationship between all of them, then it gets easier and easier. So now what I need to tell you is that when we're talking about different units, mostly in biology, and it's not in all sciences, but in biology, we will usually talk about different units of measurements, and we will talk often about units of volume, right? So units of volume, and in that case we're talking about liters. We might be measuring weight. Okay, so weight, and then weight, we would measure the weight in grams, and also maybe length, right? Length, and then length would be measured in meters. Okay, so just to tell you a little bit about those values. Now, there are other units we can use. Of course, these three are not the only ones that we use, but those are probably, I would think, the ones that we use most of the time. Now, what we need to really realize here is that some of those units here, whether we're talking about liters, we're talking about grams, or about meters, they're not always appropriate to describe what we're looking at. Let me give you an example for that. So if you have a drop of blood, right? A drop of blood should not be measured in liters per se, right? Because we will have a very small value, and a liter is bigger than that small value, right? So a liter is, we all know what a liter is. It's pretty large quantity of liquid. Well, if I'm talking about one drop of blood, as you can imagine, a drop of blood is much smaller than a liter. So we use other terms to define this. So what we use in terms are known to be prefixes. So let's see what those mean. So my point here is this. When we're looking at the relationship, and that's important here, is understand the relationship between deca and hecta. So we know that there's the difference of 10 to 100, so we have 10 times here, 10 times, right? And for example, what we have here, kilo and hecta, so 100 to 1,000, we had 10 times as well. The difference between kilo and 1 meter, so kilometer and 1 meter, is a factor of 1,000, right? Okay, so you might ask, okay, well, how come? Why is it a factor of 1,000? Well, we know that deca is 10 to the power of 1. We know that hecta is, and kilo is, hecta is the difference power of 2. And then when we look at all of this here, kilo, well, the difference between 1 meter and 1 kilometer is something right here is 10 to the power of 3, or 1,000. Now let's not get lost into this right now. I just want to establish the relationships between all of those, because they become very important when we're looking and comparing numbers in order to solve problems with unit conversions. Now I want to give you a little example here, but before I give you an example, I need to establish the first step that's going to help you solve these problems. Okay, so the first thing you need to understand, so I'm going to give you a relationship here, and I'm not going to define it quite right now, but I want to say something. Okay, so let's say that I have X that has a certain amount of units, and let's not forget we're talking about meters here, right? And then we say that X units is equal to Y units. So for example, the same way 1 meter equals 1,000 millimeters. Okay, we know that there are 1,000 millimeters in 1 meter. Okay, so not sure what happened here, but Anyway, let's resume this. So the first thing that you need to understand here is that you need to know which one. So you need to know which one of either x or y. You need to which one or x or y is going to be larger than the other one. Okay, and you could also say, well, which one is going to be smaller, right? I just decide to go, well, which one is going to be larger in number? Okay, so which one is going to be larger? So basically what I want to know is which one fits in the other one. The same way millimeters fit in 1 meter to the ratio of 1,000. We have 1,000 millimeters in 1 meter. So we need to understand and we need to answer this question. Which one is going to be the larger one, the bigger one? So let's say, for example, that I have this problem here. I want to know how many millimeters are found in 2.65 kilometers, right? I want to know what is the value of x. X in this case equals what, right? We don't know that. Well, the first step here is to try to understand which one will be the biggest one. Okay, so will I have a lot of x here? So bigger than 0. So basically, is it going to be 10 to the power of something that's positive? Or is it going to be 10 to the power of minus, right? 10 to the minus something. So are we going to have a number that's bigger than 2.65 or a number that's smaller than 2.65? Well, here's a trick. We know that millimeters as a unit are smaller than kilometers. We know that, right? So which means that there are more millimeters in kilometer than there are kilometers in millimeters. Okay, we know that. So the number x will, for sure in this case, will be larger than 0. Okay, will be larger than 0, and actually it will be larger than 2.65. Now, the step two, okay, step 2 is this. Step 2 is to understand the relationship, right? The relationship between millimeters and, of course, kilometers. We need to understand the relationship between those two. So what is the relationship between those? So here's the relationship between the two. We're talking about meters. Don't forget that. Okay? So we want to know the relationship, what is the difference and how big the difference is between millimeters and kilometers. And we're talking about meters here, right? This is our go-to point. This is our unit of measurement. We're talking about meters. So we know that when we're talking about 1 kilometer, that is 1,000 meters. 10 to the power of 3, right? 1,000. 10 to the power of 3 on that side. And that side here is a unit. The kilometer is bigger than the meter. When we look on the other side, when we look on the other direction, in the other direction, right, we know that a millimeter, we need 1,000 of those to fit in 1 meter. So a millimeter is 10 to the minus 3. It's 1,000 times smaller than a meter, right? It is 1,000 times smaller. That's why we have the minus 3, while a kilometer is 1,000 times bigger than the meter. So the difference between those two here, the difference between this one and this one, okay, the difference between those two, so when we look at those, right, the difference between those two is 1,000 times 1,000, right? 1,000 on that side and 1,000 on that side. Or 10 times to the power of 3 multiplied by 10 times to the power of 3. And now you might say, well, wait a second. This is minus 3 here, right? It's not power to the power of 3. Well, it doesn't matter. It's 1,000 times different, okay? So we're just measuring the magnitude of difference between the two of them. So when we multiply 1,000 by 1,000, we know that is equal to 1,000,000, which is 10 to the power of 6, right? So when we're doing this, 1,000, 10 to the power of 3 times 10 to the power of 3 equals 10 to the power of 6. When we multiply exponents, we actually add the exponent. We have 3 plus 3 equals 10 to the power of 6, okay? Now, when we want to solve this problem here, 2.65 kilometers equals how many millimeters? We know now that there is a difference between millimeters and kilometers. We know that there's a difference of a million in between, right? And we know that our number here, x, will be larger than 2.65. We defined that already earlier, okay? So what we need to do now is multiply 2.65. We multiply that by 10 to the power of 6, right? Because that is the difference between our two subunits. So this will be equal to x. All I did is multiply 2.65, and I multiplied 2.65 by 1,000,000, which gives us 2.65 times 10 to the 6th millimeter. So we know that there are 2.65 million millimeters in 2.65 kilometers. Now let's do like another calculation. So here's my problem here. I'm asking 17.32 micrometers, okay? How many milliliters is that? Like how many times do I have, how many millimeters do I have in 17.32 micrometers, or how many 17 of those 17.32 millimeters do I have in micrometers do I have in milliliters, right? So we need to establish the relationship between millimeters and micrometers. And in this case here, we know that millimeters is 10 to the minus 3, and we know that micrometers is 10 to the minus 6. Okay, so we know that. So the difference, the order of magnitude in between is actually only a factor of 1,000, or 10 to the power of 3, which equal to 1,000. Okay, we know that. So now we need to establish which one is the biggest one. Which one will be the bigger number? Is it 17.32? So is it on the side of micrometers, or is it on the side of millimeters? Well, we know that micrometers is a smaller unit than millimeters, right? There's more micrometers that fit in millimeters than there are millimeters that fit in micrometers. Actually, no millimeter can actually fit in 1 micrometer. So we know that the number here, x, will be smaller than 17.32. Will be smaller how much? Will be smaller by a factor of 1,000. But because it's smaller, it's not 10 to the 10 times the power of 3. It will be 10 times minus 3. So all we need to do now is 17.32 and multiply that by 10 to the minus 3. So we will, in 17.32 micrometers, the value of this converted into millimeters is 17.32 times 10 to the minus 3. Now, this is not completely correct. And the reason for this is that when we look at the scientific notation, we know scientific notation only has before the decimal, right? We only have one number. So what we have here is 17. That's not correct, right? So we will have, actually, if we convert this correctly, we have 1.732 times 10 to the minus 4 millimeters. Okay, so 1.732 times 10 to minus, sorry, not 4, but 2, because I moved the point right here, right? So 10 to the minus 2 millimeters. So I have 117.32 micrometers is equal to 1.732 times 10 to the minus 2 millimeters. Okay,